When you drive past a massive industrial construction site, like maybe a new power plant or a sprawling oil refinery, it's so easy to just see pure chaos.
Oh, absolutely. It just looks like total mayhem from the outside.
Right. I mean, you have these giant crawler cranes swinging in the sky and sparks showering down from welding torches everywhere. Thousands of people just crawling over these steel structures in the mud.
Yeah, it looks completely unscripted, like this organic, messy process of just wrestling metal into the ground until, a factory suddenly appears.
Exactly. But then if you look behind the curtain at how these mega projects are actually managed, you realize that every single spark, every bolt, every swing of that crane is rigidly scripted, like down to the exact cent.
It really is. It's the absolute definition of a controlled matrix.
Let's
It looks like physical chaos to the untrained eye is actually just, well, the three-dimensional manifestation of an incredibly strict set of spreadsheets and contracts.
And that is exactly why we are here. Welcome to today's deep dive. Today, we're handing you the key to that matrix. We've got a really fascinating stack of sources in front of us, primarily the FIDIC Red Book unit rates for construction preambles.
Yes, and we're specifically looking at the accompanying mechanical unit rate schedules for an EPC contract. And for anyone listening who might not know, EPC stands for Engineering, Procurement, and Construction.
Right. And our mission today is to decode this seemingly impenetrable wall of construction unit rates. We are focusing exclusively on the mechanical unit rates because, if you want to understand how the beating heart of a billion-dollar industrial project is priced, categorized, and built, this documentation is the DNA.
It really is the DNA.
Yeah.
Without it, the whole thing falls apart.
Okay, let's unpack this, because if you look at these spreadsheets initially, they just look like an endless phone book.
Oh yeah, just walls of text.
Literally thousands of rows of numbers, acronyms, vague descriptions, but they're actually a hyper-specific, shared language that prevents total financial ruin on these sites. Without this language, a project of this scale would just descend into endless lawsuits within a week.
Totally. And what's really fascinating here is how this language operates operationally in the field. To bring order to the chaos, the employer, so the people paying for the plant and the contractor, the people actually building it, rely on a system called the WBS.
Ah, the WBS. So looking at the sources, this stands for Work Breakdown Structure, right?
Exactly, work breakdown structure. It's a 7-level code used to identify every single object or task on the entire project.
It kind of makes me think of a supermarket barcode. Like,
Sure.
you scan a barcode at the register, and the computer instantly knows it's not just a beverage, but it's a 12-ounce can of sparkling water, and it costs exactly $1.99.
That is a highly accurate analogy, actually.
Except here, instead of scanning a can of water, you're scanning a multi-ton industrial compressor.
Right, exactly. So let's walk through how a specific piece of mechanical equipment gets its barcode and, more importantly, how that impacts the reality on the ground.
Let's do it.
So the first couple of levels are for the general project name and the geographic area of the site, but level 3 is where it starts getting discipline specific. For our focus today, the code is ME.
Which stands for mechanical equipment, I'm assuming?
Precisely. ME instantly tells the billing department and the engineers, we are dealing with a machine, not a concrete slab or a structural steel beam.
Okay, that makes sense. It routes it to the right people.
Right. Then we move to level 4, which dictates the material. When the mechanical schedules we're analyzing, level 4 is universally coded as M01.
M01. And what does that stand for?
It simply means any material.
Oh, okay. Which is pretty logical, given that a giant machine isn't just one thing. It's, carbon steel, stainless steel, rubber gaskets, copper wiring, all just mixed together.
Exactly. You couldn't possibly code every individual material inside a complex pump. It would be a nightmare.
Yeah, that would be impossible.
So now, level 5 is where the financial action actually happens. Level 5 defines the activity. And for our mechanical equipment, we are looking at code 200.
Okay, code 200. Let me check the matrix here. So 200 stands for supply, erect, and install mechanical general equipment, including testing.
Yes. So that full code, ME.M01.200, translates directly to mechanical discipline, any material, and the activity is to supply, erect, install, and test it.
But how does this actually play out on the site? Like, are engineers walking around with iPads scanning QR codes on wooden crates?
In modern projects, yeah, essentially they are. This isn't just bureaucratic red tape, It is the fundamental mechanism for getting paid.
Okay, so follow the money.
Always.
Wait,
Let's say it's the end of the month and the contractor wants to be paid, say, $5 million for the mechanical work they did. They submit this massive payment application to the employer.
Right.
If a field engineer logged the installation of a pump under code 201 instead of 200, the employer's software simply rejects it. The money just stops.
Oh, wow. That immediately raises the stakes. So if there's a dispute on site about whether a contractor was supposed to test a machine after installing it, they don't have to argue over vague meeting notes.
Exactly. The employer just points to the 200 in the code and says, look, the activity code you build against explicitly includes testing. It's not an extra charge.
It totally removes ambiguity. But the WBS isn't finished yet, right? Because we know the discipline and the activity. But installing a small water pump takes vastly different labor than installing a 3-story industrial boiler.
Vastly different, yeah.
So how does the contract tell them apart?
That takes us to level 6, which categorizes the equipment itself.
Here's where it gets really interesting. Because looking at the sources, level 6 assigns a specific 3-digit number to every conceivable type of machinery. It reads like an incredible catalog of industrial giants.
It really highlights the sheer mechanical diversity of an EPC project. It's staggering.
It is. You have your everyday industrial gear, right? Compressors get code 001, pumps are 002, boilers and heaters are 006. But then you get into equipment that sounds like it belongs in a sci-fi movie.
Oh, like what?
Well, for instance, code 015 is for pig launcher and receiving units, and
Yeah.
I'm assuming that has absolutely nothing to do with livestock.
Definitely not.
Mhm.
No pigs involved. In pipeline engineering, a pig actually stands for a pipeline inspection gauge.
Okay, so what is that exactly?
It's a massive, heavy device that is literally launched through miles of pipe to clean it or to inspect the welds from the inside.
Oh,
Yeah, and the launcher and receiver units are these heavy-duty pressure vessels with massive steel doors to insert and remove these devices safely, all while dealing with immense pipeline pressure.
that is wild. And then there's code 016, which is for flare tips.
Right, so the flare tip is the specialized burner at the very top of those giant towers you see at refineries.
The ones with the giant flames shooting out of them.
Exactly. They're used to safely burn off excess gas. Installing one of those is a massive mechanical challenge because you're lifting an incredibly heavy piece of precision engineering like 300 feet into the air.
Which leads perfectly into the final level of our barcode, because we know it's a pump or a flare tip, but level 7 classifies all of these machines by weight. The final 3 digits of the WBS dictate its weight class.
Yes, the schedules categorize everything into 11 distinct weight bands.
Yeah.
So code 001 is for equipment weighing less than 1 ton each.
Okay, pretty light stuff.
Right. And it scales up incrementally. Your bands for 10 to 50 tons, 100 to 300 tons, all the way up to code 0111, which is for colossal machinery weighing over 1,000 ton above each.
Over 1,000 times. I mean, that is hard to even conceptualize. But looking at the preambles, there is a very strict rule about how that weight is calculated. And this feels like a scenario where a contractor could take a massive financial hit if they misunderstand the rule.
Oh, a catastrophic hit. Section 3.2b of the preambles dictates that the weight category is determined strictly by the dry weight specified in the official equipment list.
Wait, hold on. If we're dealing with heavy lifting, let me ask a practical question here.
Sure, go ahead.
Say a machine's dry weight is 900 tons. That puts it in the 0-ton class, right?
Correct.
But to actually lift a 900-ton machine safely without crushing it, you usually have to bolt it to a custom structural steel lifting frame. So if that frame weighs 200 tons, the crane is picking up 1,100 tons. Does the contractor get to bill for the 011 class, since the total weight being managed is over 1,000 tons?
You would naturally assume so, right?
Yeah.
Because the physical risk and the crane capacity required are based on that 1,100-ton total. But the Avitai rule here is unyielding.
Uh-oh. So they don't.
No allowance whatsoever is made for slings, lifting frames, packing, or any temporary rigging. If the machine itself weighs 900 tons, you are paid the rate for the 900-ton class.
You are kidding me.
Nope. The cost of designing, building, and lifting that 200-ton frame is entirely your problem.
That seems incredibly rigid. It means the contractor is carrying a huge margin of uncompensated risk just to move the object into place.
It absolutely does. But it perfectly illustrates the central philosophy of these unit rates. If you look at the composite rate column in the schedule, next to every machine's quantity, there is a composite rate.
Right, and that's broken down into material cost, labor cost, and man-hours per unit.
Exactly. This single rate is the firm fixed price for supply, erect, and install.
And looking at Section 1.1 of the preambles, the sheer volume of inclusions baked into this single rate is staggering. I mean, it reads less like a pricing sheet and more like an ironclad defense shield for the employer.
That's a good way to put it.
It reminds me of the contract for an all-inclusive resort. The employer is paying one fixed price, and their expectation is zero hidden fees.
The all-inclusive analogy is perfectly apt, but here, the stakes are millions of dollars. The general preambles state that this rate must cover management, supervision below the general foreman level, overhead, and profit.
Which is standard, but then it gets crazy.
Right, it gets highly operational very quickly. For instance, the rate includes the supply, erection, and dismantling of all scaffolding required.
And scaffolding on an industrial site isn't just a couple of metal poles. It's a massive undertaking.
Oh, it's an entire sub-industry. Building a safe, multi-level scaffold around a 100-foot-tall distillation column takes specialized crews, weeks of labor, and daily safety inspections.
And the employer isn't paying extra for any of that.
Not a dime.
Mm-hmm.
The contractor has to accurately estimate exactly how much scaffolding they will need just to install that one column and bury that cost inside the mechanical installation rate.
That is a massive variable to estimate years in advance. And the list of inclusions just keeps going. It mentions small tools, consumables, temporary supports, and all NDE testing, non-destructive examination.
Right, like X-raying or ultrasonic testing of the critical welds on the machine's piping connections.
And bringing in specialized third-party X-ray technicians, clearing the area of workers due to radiation, processing the results, that is incredibly expensive and time-consuming.
It is. It really is. And if we look at Section 1.5K, there is perhaps the most punishing inclusion of all.
Oh boy, what's that?
The rates shall include the cost of carrying out remedial work caused by the contractor's own method of working or by flawed trade operations.
Wait, meaning if a welder messes up a connection, they don't just cut it out and re-weld it. They have to pay the X-ray technician to come back, test the new weld, and eat the cost of the lost time.
Exactly. The employer pays exactly $0 for the correction.
That is brutal.
The contractor is flying without a safety net once that composite rate is locked into the contract. Which brings us to a really highly debated quirk in the mechanical equipment preambles regarding reassembly.
Okay, yeah, let's get into this because this caught my eye in the sources. Often, these massive pieces of equipment arrive at the site as packaged units, right? Like they're shipped in multiple pieces because you can't exactly strap a fully assembled 4-story boiler to a truck and drive it down the interstate.
Precisely. Transportation logistics dictate that these machines are broken down. So Section 3.2b says that the contractor's installation rate automatically includes the reassembly of any components that the manufacturer disassembles for shipping.
Okay, so like what kind of components?
The examples provided are reinstalling removable handrails, ladders, stairs, platforms, and external exhaust ducts. If it was taken apart just to fit on a ship, the site contractor has to put it back together as part of their fixed installation rate.
Wait, hold on a second. Doesn't that just incentivize the factory manufacturer to do a sloppy job? Like, to just throw a bunch of loose parts into a crate to save on shipping costs, knowing the poor site contractor has to clean up the mess and reassemble everything on their own dime?
Yeah.
How is that fair to the site team?
That's a very common grievance on these projects, actually. But the preambles draw a very strict line here to prevent exactly what you were describing.
Oh, they do.
Yes. The rate specifically excludes unfinished carryover or punch list work that the manufacturer simply failed to complete.
Okay, so how do they define the difference between disassembled for transport and the factory was just lazy?
Well, the sources give explicit examples. If the manufacturer failed to install internal vessel packing, or if they skipped the factory testing and painting of internal pipes and instruments, the site contractor is not expected to finish the manufacturer's job for free.
Ah, okay, that's a relief.
Right. The employer would have to pay the site contractor extra to finish the manufacturing, and then the employer would likely backcharge the factory. The fixed rate only covers putting together the specific pieces removed for transport clearance.
If we connect this to the bigger picture, it really transfers a massive amount of logistical risk onto the contractor.
It absolutely does.
So what does this all mean? If you're listening right now, maybe you're managing a team in software or logistics or manufacturing. How do these rigid EPC rules connect to your reality? Because to me, it feels like there is a deeper management philosophy at play here beyond just construction accounting.
There absolutely is a deeper philosophy. It is about driving operational behavior through unyielding financial boundaries. Let's look at the rule regarding waste in Section 1.4 big.
Okay.
It states, All items of work are measured net as fixed in position, and no allowance is made in the quantities for waste.
Net as fixed. So let me get this straight. If the engineering blueprint says a mechanical connection requires exactly 10 meters of specialized steel pipe, you get paid for exactly 10 meters.
Correct.
Now, in the real world, you can't buy exactly 10 meters. You might have to buy a standard 12-meter length, cut off 2 meters, and throw it in the scrap bin.
Yep.
You are telling me you're not compensated for that 2 meters.
You are not. The rates are deemed to include your cutting margin, your waste, and your disposal fees.
But come on, waste is a physical inevitability in construction. You can't perfectly estimate cuts in fabricated joints.
You can't. But the employer's philosophy is, they are buying the finished plant, not funding your learning curve or your sloppy cutting habits.
Right.
If a worker drops a 2-meter pipe cutoff in the mud, that is quite literally the contractor's profit margin dissolving into the dirt.
That is a brutal incentive to measure twice and cut once. I mean, my goodness. And it gets even tougher when dealing with site conditions, right?
Oh, yeah.
Because under Section 1.1e, it says quantities and rate supply, regardless of difficulty, location, complexity, and whatever method the contractor may adopt.
Yes.
Yeah.
There is zero allowance for hardship. None.
I noticed in the mechanical preambles, it explicitly states that grouting is deemed included in the rate for equipment installation. And for the listeners, grouting is basically pouring a specialized high-strength concrete under the metal base of a heavy machine to perfectly level it and absorb its vibrations.
Right. Very critical step.
So if pouring that grout is an absolute nightmare because the machine was placed in a dark, cramped corner with barely an inch of clearance, it's just expected.
Yes. Even if the civil contractor poured the foundation slightly awkwardly, making the mechanical contractor's grouting process twice as difficult, the mechanical composite rate does not change.
Man, this raises an important question. Why structure a multi-billion-dollar contract this way? Why be so seemingly inflexible and combative with the people building your plant?
Because it forces extreme, relentless efficiency. By making the contractor absorb the cost of waste, the cost of scaffolding, the cost of NDE testing, and the cost of sheer difficulty, the FIDIC rules incentivize the contractor to work as smartly, safely, and cleanly as humanly possible.
I see.
Think about the alternative. If the employer agreed to pay for waste, the contractor would have no incentive to optimize their material orders. If the employer paid extra for difficulty, every single task on a 3-year project would suddenly be documented as unusually difficult.
Right. Everyone would suddenly be having a very hard time. So it aligns everyone's interests by capping the employer's risk. The employer gets absolute budget certainty, and the contractor is highly motivated to innovate, manage their supply chain tightly, and find the most efficient way to get the machine bolted down.
Exactly. It creates an environment where only the most ruthlessly organized companies survive. It filters out incompetence very quickly.
We've covered a tremendous amount of ground today. I mean, we've seen how a 7-level WBS barcode turns the apparent chaos of a job site into a precise, manageable matrix. We've talked about how mechanical giants, from pipeline pig launchers to massive flare tips, are classified purely by their dry weight, totally ignoring the massive lifting frames needed to move them.
Yep.
And we unpacked how a single composite unit rate acts like an ironclad shield for the employer, hiding an entire universe of risk, scaffolding, testing, and labor inside one number.
It is a truly remarkable system.
Yeah.
And to close out, I want to leave you with a thought regarding the future of this industry, driven directly by these very rules.
Oh, let's hear it.
We discussed how Section 1.5G of the Preambles states that these unit rates shall apply equally to executing the work in large or small quantities, at all elevations, in all positions, and at all locations.
At all elevations, meaning the check is the exact same whether you're on the ground or in the clouds.
Exactly. A contractor is locked into the exact same installation rate for a 100-ton heat exchanger, whether it's being bolted onto a flat concrete slab right on the ground, or if it's being hoisted 200 feet into the air amidst heavy winds, slotted into a towering steel structure.
Wow.
The financial payout is identical, but the labor, time, and danger are exponentially higher.
So how do they even make money on the high elevation stuff?
Well, that's just it. Because these rates are so unforgiving, and because contractors can't charge more for difficulty or elevation, they are forced to find new ways to scrape back their profit margins. This strict contractual environment is exactly why construction companies are currently pouring hundreds of millions of dollars into robotics, AI scheduling, and drone surveying.
Oh, that makes so much sense.
When your labor rate is locked, the only way to make money at 200 feet in the air is to send a drone to inspect it, or an automated robotic crawler to weld it, rather than paying a human crew for a week of scaffolding. The rigid rules of these FEI contracts are directly accelerating the technological evolution of the construction site.
That is fascinating. The contract literally forces the invention of better technology just to survive the math. It really changes how you look at the world. I mean, the next time you drive past one of those sites and you see the cranes swinging and the sparks flying, remember there's no chaos up there, only the matrix.
Only the matrix.
Thanks for joining us on this deep dive.
If you're interested in the templates, please visit our shop. The link is in the description.
Thanks for watching. Please subscribe and see next time.